at one of the local Chattanooga parks working on a drone survey, and today we're going to take you up into the sky to show you the basics of how easy it is to actually take your drone up, do a quick orthomosaic map, and take a 3D model of whatever image you might want to take. So we've got our Phantom 3 Pro here. It's got 4K resolution for the video and 12 megapixels for the picture, for the images. We've also got the standard controller that comes with it, nothing fancy. I'm actually using just my cell phone with it. It doesn't take any fancy tablet. You just plug it up and straight go from there. So we've got our setup for our ground control point units. We're gonna do 4 of them out here today. We're gonna set them at the different corners of the site. And we've also got our GPS unit that we're gonna use to take high accuracy ground control points. So I've got one of my ground control point units here. I'm gonna put the GPS unit right in the middle of it so that I can get accurate measurement, and what it does is it gives the drone a relative area so that the elevation based off the GPS unit can tell it exactly where it is in real time. You can give it elevation data and it can also give it horizontal accuracy. So we've got 1 point recorded here, and we're going to do 3 more going around the whole site just so that we can have the whole site contained and know exactly the elevation that we're going to be working with. So let's the GPS get it actually locked on to all the satellites that are here to make sure that it's actually doing what we need it to do. Alright, so I've got the mission loaded into the drone. I'm going to send it up, and it should be an autonomous flight from there. we've got the data syncing up right now to the drone. Well, after this, we're going to take you back into the office so that we can get it all uploaded. We're going to turn it into a 3D image. We'll also turn it to a 2D orthomosaic.
So we're going to start off by importing the images with the elevation metadata into WebODM. Here we can change a few of the options to optimize the quality of the processed data. I have my images set to 1000 pixels because with 32 gigabytes of RAM, my system can only process about 60 images at a time. The developer recommended that with WebODM, at least 4 gigabytes of RAM is necessary to run the software, but in my case, 16 gigabytes weren't enough to process this model. So along with the 16 gigabytes of extra memory, I'm currently running an i7 Intel processor with an NVIDIA GeForce GTX 950 graphics card. As the images take some time to resize and process, I will skip ahead. Okay, it took about 24 minutes to complete. And let's check out the ortho images that were generated. There are a few small images that we can correct in QGIS, but ultimately this map turned out well. We can clearly see what's going on at the site, and our image is higher quality and more up to date than what Google satellites depict. There are a few neat things you can do with the tools on the right side. We can measure length, area, and volume, all of which can be exported as a GeoJSON, which can be imported into QGIS. It's also much easier to create contours from the digital surface model generated by WebODM, which we'll later import into QGIS. Here we can also take a linear measurement from the two different points of elevation. There's also a plugin that allows you to analyze plant health, so if you work in the agricultural field and your drone has a multispectral sensor, you have additional options. Here is the digital surface model, which is created by combining the locational data and the aerial imagery to generate a model that can display the elevation above mean sea level. Next, we can see what our 3D model looks like. The grid above the model depicts the location of the camera at the time the photo was taken. You can click on the icon and it will show you the image associated with it. The software can be beneficial for anyone working with crime scenes, emergency relief, construction, asset management, and plenty of other opportunities in the agricultural world. There are a few other options here on the left that you can mess around with, and some will allow you to manipulate the size of the point cloud, which will allow you to analyze your data in higher quality. There are a few other options here on the left hand side which you can feel free to dive into. I didn't say it before, but this software is free. You have to go through a few hurdles to install it, but it is free. Now that we've deselected the texture model, we can accurately see how the cloud point model changes once we change the nodes. There are some clear holes in the model, and according to one of the developers, these can be eliminated by performing multiple flights. We can clean up the area of interest with the clipping tool. This will allow us to eliminate some of the messier sections of the model without losing quality. Next, we will skip over to QGIS, where we will make a shapefile from the text that we created from the ground control points that we collected in the field. With the use of our measurement tool, we can tell that we're about 11 feet off, so we will try to georeference the area to align the map. Now that we can tell that we're about 11 feet off the Google satellite image, we can georeference the ortho map with If done correctly, we should have an accurate map that is aligned to the ground control points. Lastly, we can drag over the contours that we exported from WebODM to create a digital surface model, which can be used to create hillshades and an elevation model. The last thing we're going to do is label the values of the appropriate data to display what is above MCL. With a simple drone, WebODM, and QGIS, we can create our own digital surface models and generate up-to-date orthomosaic images in real time.